Can OpenBSD compete with Linux on the desktop? Stay until the end to see the full install, XFCE and benchmark performance. We enter the website, go to Downloads, and choose the IMG for USB. The ISO image does not work for USB, only for CD/DVD. In the terminal, we run ls-blik to see the device name and write the image with dd. This way the boot process will work fine. We boot the image. The latest version is 7.9 based on Unix 4.4 BSD. For the default options, we just press the Enter key. The first step is to press I to install. Then we enter the keyboard layout and the computer name. I entered OpenBSD here. Then the network interface. I will use Ethernet, so I press Enter. Same to auto-configure IPv4, IPv6, then Enter to finish. It automatically sets the required network configuration. Then it asks for the root password. We enter it and confirm it. Now it asks if we want to start X with Xenodem. We press Enter for no. On large screens, this system is not very visible. Then we add a user by typing the username, which is highly recommended. We enter the full name, password, and confirmation. The OpenBSD philosophy is secure by default, so we select not to allow root logging via SSH. Then we enter the time zone. Now it shows the disks and asks which one to use. We select it and also leave the root disk unencrypted. We choose GPT. Then it shows the partition layout for the disk. We press Enter to accept the auto layout. Then we press Enter to finish. We are going to install the sets. It asks if via HTTP, if a proxy is used, and the mirror. Press question mark for the list. It will show the list of available mirrors. We press Enter to scroll through the list and select the one located closest. There are 111 mirrors in total. I will select number 106 from Berkeley. Then we press Enter to confirm all chosen sets. With this, the system installation process will begin. OpenBSD mentions on its site that its efforts focus on portability, standardization, proactive security, and integrated cryptography. As an example of impact, they say OpenSSH comes from it. By pressing R, we reboot the installer. The system will boot for the first time. We wait for it to finish to see the login. We log in as root and type the password. We will only use root to install and configure the desktop environment variables. We use the pkg-add command to install packages. We add XFCE, Xtras, dboss, and dboss-glib. We install the XFCE and extra packages for the desktop, dboss for app communication, and dboss-glib for GUI compatibility. We enable the message bus service with RCCTL enabled to allow internal communication between apps. We start it with start. Then we enable IPMD with RCCTL enabled to improve power management and battery saving features. Then we start it with start. With user mode, we add the user to wheel for admin permissions with DOAS, and to operator to power off, reboot, or manage it. With the echo command, we add a rule in doas.conf so wheel users can run administrative commands without a password prompt. We enable Xenodem to automatically start the graphical login manager when booting OpenBSD. Then we log out of the root session. The login screen will appear. We enter the username we will normally use and the password. With this user, we start the GUI. With the echo command, we will save the exec in X session to configure XFCE and to start automatically upon graphical login. With this, we finish configuring the desktop environment. We run DOS reboot to restart the machine. DOS is like Linux sudo. On this system reboot, Xenodem will automatically load to log in with the user, and then it will load the desktop automatically. We enter Zenodem and see the graphical login with the logo. We enter the username and password, then wait for the environment load. Now we check the desktop, the dock, the panel, and the menu. We see it has the default applications installed for the desktop. After checking the environment, we open the terminal. We increase the font size for better visibility and enlarge the window size. We use DOS pkg-add to install Fastfetch and see system information. Then we install sysbench, which will be used for testing. We run Fastfetch. We see the kernel version, the desktop environment, idle memory, and the megabytes per package are excellent. We run commands to contrast the information. We see the exact same version of the operating system and kernel. Both are 7.9. Then we check memory and see it reserved 1 GB. But active memory is 255 megabytes, an excellent lightweight consumption. We run sysbench to measure processor performance with a single thread. The result gave us an average value compared to Linux. Then we test processor performance with 5 threads. Again, it gives us an average result. Remember, we are using version 04. Now, we will analyze the threads directly to measure the concurrency level handled by the system. The result was average 2. To analyze the efficiency of system logs, we will use mutexes with 5 threads. The result obtained was an average 1. Then we will evaluate the memory read speed to measure read performance. The result in this specific case was quite low. In the same way, we will evaluate the memory write speed, changing the parameter. The result was also low in this benchmark. Now, we prepare the files needed to perform a disk input and output test. This version does not provide the actual speed. We use the dd command to test sequential writing of 1 GB. The sequential speed result is very good for this disk. Now we run the filio test to measure random read and write speed. The reading is excellent and the writing is average. We run top to measure the amount of memory used by Firefox. When running it, it is not installed, so we proceed to install it. Then we run top and Firefox. We load a website to measure the consumed memory, then a second tab playing an online video. Now we open a third and a fourth tab while observing the consumed memory. The average memory consumption per tab is excellent. A limitation for using OpenBSD as a desktop is the NVIDIA driver restriction, as we can see with the executed commands. This is due to the philosophy of the system and because it is not a priority for common OS usage. We now install GL Mark II. We run GL Mark II. This test is performed on the default card, which is Intel. It tests textures, shadows, and 2D effects. It also tests desktop elements, image transparency, refraction, conditionals, and loops. The result gave a very good score. We have finished the OpenBSD tests. We close everything and power off the machine to give results. Shutdown is not enabled. For this version, the operator group was not enough, so we must add the shutdown group. Then we log out and restart session. Logging in again with the credentials, we can notice that the shutdown option is now enabled. Then we turn off the computer. In conclusion, it is feasible to install a desktop environment on OpenBSD, being very stable. It is even easier than FreeBSD. Regarding NVIDIA, we mentioned that due to philosophy and priority, it cannot be configured, even more on dual-card laptops. Regarding performance compared to Linux, it has excellent and average aspects. Out of 60 distros, it is in the top 30. That is all for this video. If you liked it, subscribe, leave a like, and turn on notifications. See you in the next video.